The script task automatically declares a class named script main and adds a method named main to it. When the script task executes in the package's control flow, it creates an instance of the script main class and calls the main method. This is the standard entry point to your script and where you add your custom code. You can make your code as complex as you want by defining additional properties, methods, and classes, but most of the time this is going to be unnecessary for simple use cases. One of the main tools inside the script task is the global DTS object. This object is an instance of the Microsoft.SQLServer.DTS.task.scripttask.script class and provides access to the package in which the script task runs. The DTS object has properties and methods that enable you to access the variables and connection managers in the package and let you raise events, log errors, warnings, and information about your script execution. You can also inform the integration services runtime about the success or failure of the script task's execution. The DTS object doesn't have any properties or methods that allow access to other tasks within your package. Microsoft deliberately omitted this functionality from the integration services runtime. The reason they did this is because it's dangerous for one task to access the properties of another. It makes packages difficult to maintain and debug and generally results in spaghetti code. Integration services tasks communicate with each other through variables. If one task needs to pass a value to another, it has to set the value of a variable and the other task can then use that value. Although this may sound like a step backward from SQL Server 2000's DTS, where there was an anything goes mindset for cross-task script access, it is actually a major improvement in integration services for developing stable ETL solutions. The final step in any script task code should be to set the task result property of the DTS object. You can set this to either success or failure, which are values of the script results enumeration. This value notifies the integration services runtime whether the task succeeded or failed, and the runtime then uses that value in the package's control flow logic based on the precedence constraints that you configured. If you don't explicitly set the task result property, integration services assumes that the script always succeeds. Since this isn't always the case, it's a best practice to always explicitly set the task result property in every script task. And as a practical matter, you're probably going to have multiple paths of execution through your code. And maybe in a catch block, you set it to failure, but in the try block, assuming that nothing bad happens, then it's set to succeed. So there's a lot of different ways to handle setting that result value. Okay, so as I just talked about, variables are the mechanism that integration services uses for communication between tasks within a package. So how do you use variables within your script task code? Well, there's two options available. One is the DTS variables collection, and the other is the variable dispenser object. All right, so first I'm going to talk about the variables collection. So the first option requires that you inform the script task which variables it can access before opening Vista. And it is an iterative sort of thing, so if you open up Vista, realize that you forgot to declare a variable, you can go back in and add it later. And then reopen the Vista again, and you'll have access to that variable. So it's not a one-time set in stone sort of thing. Okay, so where you do that is in the Script Task Editor dialog box, where you can specify the variables that the code within the script task is going to access in read-only or in read-write mode. This causes Vista to populate the DTS object's variables collection so that you can access them via code. If your code attempts to access a variable that you did not list in the editor dialog box, an error is going to occur. An error will also occur if your code attempts to change the value of a variable that you listed as read-only in the script task editor. Now, it's important to understand that integration services variable names are case sensitive. So if you misspell a variable name or capitalize it incorrectly, your code is not going to be able to access that variable. So you have to spell it the same way, including case, in the script task editor as well as within your code. Now, to access the variables listed in the script task editor, you use the variables property of the DTS object. And this property is a collection that contains all of the variables available to the script task. You access specific variables by name using code like this. So there I'm using dts.variables, the string myInteger. So that's to read it, and you can write to it in the same way. So in this very simple example, the code reads the values of two package variables, myInteger and myString. If the variables are read-write and you change their values, any task that reads the values later in the control flow will detect the modified value. You need to convert or cast the value returned to the data type that you need. That's why I'm using convert to int32 and using the toString method for those two variables. Now you should generally access variables in code using their fully qualified names. So this previous code that I showed you would be better written like this. In this case, I'm including the namespace. And by doing that, I avoid ambiguity problems if you have variables with the same name in scope that are in different namespaces. And both these variables, because they're custom variables, are in the user namespace. And then another variation is that you can reference variables by their ordinal position in the collection. So if you were to rewrite the previous code to use ordinals, it would look like this. So DTS variables 1, DTS variables 2. Now it's important to understand that the ordinal position refers to how you list the variables in the read-only variables and read-write variables properties of the script task. So look at this figure, which is a screen capture of the script task editor. Okay, so as listed, file name would be ordinal 0 because it's the first variable in the read-only variables property. And then myInteger is ordinal 1 because it's the next listed. It's the first in the read-write variables, but it's the second variable in these two different properties. And then finally, myString is 2 because it's the third variable that's listed in these two properties. So file name is 0, myInteger is 1, and myString is 2. So obviously 0 based. Now, referencing them by ordinal positions is a mixed bag. By referencing them by ordinal position, it provides better performance when executing the package because integration services doesn't need to do a lookup step when accessing the variable. But it poses a risk. If you come back later and add another variable in the read-only variables property, which is that first of those two properties, then myInteger and myString get bumped to ordinal positions 2 and 3, not 1 and 2. And if you've written code inside the script editor that assumes they're at 1 and 2, like the previous code that I showed you, you'll introduce subtle, hard-to-find bugs. So even though they're tempting because of performance, use them with caution. Okay, so that's how you reference variables or access variables using the DTS variables collection. The other way to access package variables from within your code is to use the variable dispenser object of the DTS object. This object allows you to access any variable defined within your package, regardless of whether you've listed it in your script task properties. This probably sounds attractive, but there is one big catch. If you use the variable dispenser object to access package variables, you need to handle all the bookkeeping yourself, which means that you have to write code to explicitly lock each variable as you access it to ensure that no other task can access the variable while you're changing it, or vice versa. Since integration services executes tasks in parallel when possible, this is a major concern. If you access variables, on the other hand, through the variables collection, as I previously described, integration services does all of this locking and unlocking for you. Okay? So it's a big difference in the two techniques. So here's a typical example of how you'd need to use the variable dispenser object to access a variable. It uses the lock1forRead method to lock the myString variable and then populates the vars collection variable with the current value. Once the code grabs the value and puts it in the S variable, it unlocks the variable. Notice that you call the unlock method on the variable's property, not variable dispenser. So it's a little bit weird on how you lock it and then unlock it because you're doing it on different objects. Now, the lock1 for read method locks just one variable, but you can lock all variables with the lock for read method, a similar method that's available. Then you need to call the getVariables method to populate the vars collection. So the code in that case is similar to what you can see here, but a little bit different to accommodate the multiple variables.